Today's podcast, I'd like to talk about Ohm's law and power. So essentially, Ohm's law describes the behavior of certain materials. Essentially, the most common one is resistors. And essentially, Ohm's law says that the current is proportional to the change in potential. So what this means on a graph is if you plot current versus the change in potential, you'll get a linear relationship where the slope of that line is related to the resistance, or inversely related to the resistance. And so this defines ohmic materials, behaves in this way. There are other types of materials, right? And these are non-ohmic materials, and so this could be things like a light bulb filament, diodes. There's lots of different kinds of circuits out there, and so I don't want you could walk out of introductory physics and think that everything was a resistor, and that's not the case. There are other types of materials that behave in other ways. Okay, but if they're linear, if the IV characteristics of that element is linear, then we say that it's ohmic. So power. So this is just going to be sort of a standard definition. Certain elements supply energy, others dissipate energy. How do we calculate the amount of energy supplied or dissipated? Well, that's the power. And in general, we define the power to be the current times the change in potential. For a battery, which is an energy source, the power of the battery is equal to the I times the change in potential of the battery, or I times the EMF of the battery. For a resistor, which is an energy sink, it sort of turns that electrical energy into heat energy. The power of the resistor is I times through the resistor, the current through the resistor times the change in potential of the resistor. So if we use our definitions of Ohm's law, if it's an ohmic resistor, then we have I times IR, or I squared R, or we could define it some other way and say I is delta V over R, and then we can write that as delta V squared over R. In order to obey the second law of thermodynamics, the power input into a circuit needs to equal the power dissipated by the circuit. Okay, so this is a way to check your results. If the power in doesn't equal the power out, something is wrong. This ends today's podcast.